Hi, this is Chapter 2, Lesson 3, Rate of Change and Slope. When you have two different pieces of information and you want to compare how they relate to each other over a certain period of time, you can use rate of change. It's also called slope. To find the rate of change, you find the change in the y values and divide them by the change in the x values. For instance, this graph shows us the fastest growing restaurant chains in the US during a specific period of time. Find the rate of change of the number of stores from 2001 to 2006. So, if we look at the graph, 2001 starts here at 7. So that means in 2001 there were 7 stores. If we go all the way up to 2006, this point is identified for us here. And of course it says 06 down here, so 2006. It's close to 35, but since the point is given to us, we know it's at 34. So what you do is you find the change in the y values. The change in values means to subtract. Take the highest one and subtract the lowest one to find the distance between the two values. So the rate of change here is, if we take 34, that is the y value. The y-axis is always vertical, so this is the y value. So 34, and the original y value was 7. So 34 minus 7. And we're going to divide that by the x values. Well, the change in the x values, x was 2006. Notice I used 2006 first because I used the 34 first. It's very important that you keep things set up exactly the way you start. Minus 2001. Well, we know that the denominator is 5. And 34 minus 7 is 27. This does not work out to be a whole number, but what we can do is either you can leave it in this improper fraction form or you can give me a decimal value. Because we're looking at the amount of stores in thousands, I'm going to go ahead and simplify this to a decimal. And so if you type it in your calculator, it should be a little over 5. So 27 divided by 5 is 5.4. 5.4 thousand. So let's just go ahead and multiply it by 1,000. And that will give me 5,400. If you just have a line and you want to determine slope, you can take the 2 points that you know are on the line and you can apply this formula, the y2 minus y1 over x2 minus x1. So I take each point and I label them point 1 and point 2. It does not matter which one you call point 1 and which one you call point 2. I'm just starting with 1 and then 2. The y2 means the y value from point 2. So remember that these are always set up as xy. So since this is the x from point 1, it's x1. This is the y from point 1, this is y1. The x from point 2, x sub 2, and y sub 2. And so we just figure slope by applying this formula. So the y2, which is negative 2, minus the y1, which is it's 4, over the x sub 2 is 1, and minus the x sub 1, minus a negative 1. This is where you need to be really careful. The problem itself says you need to subtract these two values. Because I have a negative value here, I still put the negative in there, but remember, 1 minus negative 1 creates 1 plus 1. So on top, we'll have negative 6 over 2, and we can simplify that to 3. So our slope for this problem is 3. If you get a fraction that will not simplify, like 1/5, then you leave it as 1/5. If you get something like 5/2, please do not change this to 2.5. Don't change it to a decimal. Don't change it to a mixed number and say 2 1/2. Just leave it like this. You want it to be in the form of a fraction. All right? If you're given a graph and you don't know the points, first you look at the graph to determine where is there an intersection, and you want a specific intersection. Don't pick a point that's between the grid, okay? So this one here, it looks like it's halfway, but there is no way for me to determine if it's really halfway or what if it's like 0.6. So since I can't determine that, I look for an exact location. Right here looks like an exact location. And you remember how to identify points, the x first and then the y. Since this lies on the x-axis, that means that the y value is going to be 0. So we go over -1, so this point is -1, 0. -1, 0. Now look for another one. There seems to be one right here. There seems to be one right there. I'm going to pick the closest one. It does not matter because you'll simplify in the end. This point goes over 1 for the x value, over 1, and up 1. That's a 1 there. So now I have 2 points, and I can plug in this formula. The other thing that I could do, let's say I don't want to spend my time doing a formula because I have the graph. I can count how much did the y value change vertically, and then put that number over how much did it change horizontally. Remember, if you go up, that's a positive number. If you go down, that's a negative number. For horizontal movement, if you go to the left, that's negative. If you go to the right, that's positive. So in some cases, you will have a negative value over negative value, which creates a positive slope. That's okay. Let's take a look at those two different ways. So if I start from this point, and I want to get in line with this point here, I have to go up 1. So the rising action is 1. That always goes on the top. Remember, rise over run. Rise, you get up. Okay? So up 1, and then the run is over 2. So to run to that point, I need to go 1, 2. So the slope is 1/2. Now I want to show you a different way. What if I had started from this point? I wouldn't rise to get in line with this point here. I would have to fall down. So if I went down 1, that would be -1. And then, as I just said, if I move to the left, that's a negative. So 1, 2, that makes a -2 for my run value. But look, when you simplify, this is still 1/2, which is still the same as this slope. So it does not matter which direction you go as long as you keep your signs correct. So this is how you find slope, and if you have any questions, let me know.